All right, folks. Well, Lab 6 this time. Last one. So, for Lab 6, this is basically about trying to do things a little differently in C and C++. So we're going to look at some of the things that we did in Lisp, for instance, and see if we can't do similar things in C and C++. Well, actually, first we're going to throw in an assembly language type of thing, but then most of the rest is going to be we want to try and create variadic functions in C and in C++, and we want to create higher order functions in C++ is the way we're going to go. But first off, we're going to play with a little bit of loop emulation. So for this first one, well, essentially what's going to happen is when you grab the repository, you'll find it's got 4 files in it, or well, 5 files, I guess. 2 C files, 2 C++ files, and a make file to compile them all. So what you're going to be doing is completing each of the 4 different files to whatever the specs happen to be. So for part A, so this is going to be in file lab 6a.c, so it's a C file, and what you've got is you're given a chunk of code, and the usual libraries and whatnot. It's basically just a main routine that gets the user to enter a bunch of stuff, and what you're going to do in the part where it says emulated loop belongs here is you're going to write code that behaves equivalently to a for loop, but the only things you've got to work with are if statements, labels, and gotos. So this is the, I don't know if you've used it in any of your other courses, but here you actually get to play with gotos. So we finally get to break the 160 rules. Let's see, so the idea is, of course, put labels at the sort of top of the loop and the exit point to the loop, if statements to figure out when you need to branch and which one you need to jump to, and the condition checks to carry out the appropriate actions. So the loop that you're trying to emulate is basically going through and saying for some counter I from a base value m, and while it's less than some max value n, increment by some increment value, where you'll see that those are the 3 values the user's provided. The user provides the start value, the ending value, and the amount to increment by on each pass through the loop. And again, you're just trying to, this is almost a mini assembly language exercise where we're going through and essentially using what amounts to a branch, a jump, and a label and see what we can do. There is sample output given, but again, this should be pretty straightforward, right? The loop is just going through and counting from the base value to or as high as it can without hitting the maximum value, and incrementing by whatever the increment value was. So I don't think that one should be too terribly shocking. The variadic functions in C. So this is part B, and it'll go in lab 6b.c. I should fix that. Maybe I'll do that right here and now. One sec. Okay, so let's give that one more try. So we're back in part B in file lab 6b.c, and for this one you're trying to create a variadic function, a function that can accept any number of arguments in C. And we're going to use the std-arg library as we discussed in the lectures for this. So you're going to hash include that library, and of course, the way that the variadic functions work in C using that library is the first parameter you pass is a count of how many additional parameters are coming up. So you're writing a display fractions function that's basically just taking any number of sort of numerator denominator pairs and displays them each in a format that we'll look at in just half a second here. But again, you can call this function, pass it a count of how many additional arguments are coming, and all of the arguments other than that first counter are going to be longs. So in this case, we're saying, here's one fraction that's 17.4 printed out. Here's another list with a fraction 8.3, a fraction 4 over 1, 9 over 2, 1 over 100, etc., etc., etc. And if they happen to pass an odd number of arguments, so there's one left over at the end, essentially there's a numerator at the end with no denominator, then we're just going to print a little message saying we're ignoring that one. So the sample output might look something like this, where we've got the pairs written as fractions, and if there's a leftover value at the end, we display it. So you're going to have to go through the process of writing your display fractions, right, with it expecting the count and then using the ... for all the rest, and then working through the VA start and the VA arg, and cleaning up with the VA end to go through and grab all of the elements from this. So again, I don't think that one should be too horribly difficult. It's just a matter of sitting down and playing with the std arg macros and getting used to the syntax and the fun and joy of working with that. So that's part B. Part C is actually going on and doing pretty much the same thing in C++, but with templated functions this time. So again, this is using the templated approach that we looked at in the lectures, and essentially you wind up creating one recursive version of the function that accepts kind of any number of arguments, the required ones plus more, and then base case versions where you say, okay, here's for that final call where they only pass exactly 2 arguments or only pass exactly 1 argument, here's how to deal with it. So again, we're writing that same function, display fractions. Of course, the C++ templated version, we don't have to pass a count up front. And so what it will do is if you pass exactly 2 arguments, it'll use that 2 argument case, the 2 argument version of the macro that you implemented. If you pass more than 2 arguments, then it grabs the first pair and does a recursive call on the rest, and that recursive call grabs the next pair and does a recursive call on the next, and so on until you're down to 2 left, in which case it goes back and uses the base case one. And then the only other scenario is where they pass an odd number of arguments. So you do 2 and then call on the rest, and the rest is just 1. So this is where you need that other base case that basically just says, here's an argument we're ignoring. And again, the expected output is pretty much the same, but it's a chance to go through and play with these templated C++ functions for variadic parameters. So again, go back through the lecture notes and the examples that were posted there, and we should be able to come up with that one without too much hassle. But now you're able to go through and do variadic functions in C or C++ to your heart's content. Lots of fun. And then the final one is where we want to play with higher order functions in C++. So functions that take other functions as parameters. So what we're writing is basically a version of apply that takes the function we want to apply and the 2 parameters to apply it to. So the function that we're passing this is only going to work for a function that expects 2 parameters. So we're going to write an apply binary where we're passing it a binary function, a function on 2 parameters. It's going to take this apply binary, it's going to apply the passed function to the 2 data values and return the result. All right, so I'm going to do something like, here we've got 3 different functions that take 2 values and return a value of the same type. So sum takes 2 ints, returns the sum of them. Prod takes 2 floats, returns the product of them. Conc takes 2 strings and returns the concatenation of them. So here's 3 functions that we're going to pass to apply binary. So if you take a look, here we've got a string s, and we're going to call apply binary, pass it that concatenation function, and the 2 or pass it s twice, and it should give us back a sort of hello hello string. If we call apply binary and pass it the sum and 2 integers, it should apply sum to the 2 integers, which should add them together and get the result back. And if we call apply binary and pass it a float and a couple of floating point values, we pass it prod and then a couple of floating point values, then it should go through, apply the prod function to the 2 floating point values, return a float as a result. So the ideas are nice and straightforward. It's just a matter of coming up with that version of apply binary where it's going to have to be a templated function, so it handles all the different data types. If we kind of assume that our data type is named t, then it's got to take the 2 data parameters that are both t's, it's got to return something of type t, and it's got to take this function pointer that takes 2 parameters of type t and returns something of type t. Right, so you're going through and just implementing the function pointer from that. So again, it's a matter of going through the lecture notes and the examples there where we looked at creating templated functions and passing functions or passing function pointers and applying them. And yeah, we'll create a little higher order function in C++ this time around. So between the three of them, that should be kind of a fun set of exercises to round things out, and we'll see how we go.